Not today. It's y'all. So y'all try to behave. Okay? Try not to cause a big disruption, Eugene. You know? I'm just joking. Okay. So today, what we're going to do is we're going to start our little section of applications to these exponential equations that we've been talking about. So the next couple of days will all be about the formula. And then on Wednesday, it'll be about taking these equations and kind of turning them around. So since they're exponential equations, and we're going to be turning them around, that's going to bring us back to where we were talking about logarithms. Okay? So the first thing I'm going to give you guys is a formula sheet. And that formula sheet, you're just going to keep in your possession. So when you take a test, you'll have this formula sheet with you. I won't have to write all the formulas up on the board. You'll have them in your possession. So you can start filling this out with the equations that we do. We're going to do 5 of these equations today. That'll leave us with 2 tomorrow. Should be a pretty easy day for you, I think. I have actually almost graded. What I do is I grade the front, like y'all's quiz from Thursday. I grade the front side of all my classes, and then I grade the back side. So I started second period front side, third, fourth, fifth. So I've done all the back sides, and then I started grading the back side of y'all's class, and got about halfway done, and I was like, man, I'm going to bed. This was last night. So y'all's quiz from Thursday are almost graded. I'll get them entered. Hopefully, I don't know. It won't be this afternoon. Might be. Tomorrow's pretty busy with all the Warren County crew coming to town. You ready?
Is it homework?
Huh?
Is it homework?
That's the note sheet for today. So the first sheet I gave you is the formula sheet. The second sheet I gave you is the note sheet. Y'all are going to have to bear with me while I'm teaching it, and then I'll give you the homework at the end. Sorry. Okay, so we're kind of doing formulas today, and we're kind of adding a little change to one of them. We modify one of them to do the 5th formula. So we're kind of doing 5 formulas today. And you're going to have no problem with all of them, okay? So here we go. We're going to start with equations that are often seen that we label as exponential growth. And those are doubling and tripling, okay? For example, let's say you guys have $10 at the beginning of the day, and you want to double that money by the end of the day. How much money will you have at the end of the day if you've been successful?
30.
Now, if you want to double it, you'll have 20, right? 10 to 20. What did you do? You multiplied by 2, right? And then tripling would be what? Multiply by 3. You started with 10. At the end of the day, you hope to have 30. You've tripled your money, right? So we have 2 formulas that are kind of special in the fact that you just see them quite a bit. And there's a quick formula that you can do to actually solve when your money or whatever it is that you're dealing with has doubled or tripled. So here's what it is. It says A equals, A is like the total amount, if you will. It's the total amount you would have after a certain amount of time, okay? So A equals P. P is what we would call principal, and that is your initial value. Whatever it is you're talking about, that's the amount that you start with. Easy enough, right? And then obviously the only difference between the doubling and a tripling formula is that one of them has a base of your exponent that's 2, and the other has a base of your exponent that's 3. Okay? And then your exponent itself is your time. Brady, are you distracted by something? Okay, put your phone away because obviously it's not helping you out right now. Okay? Now, when it comes to the way these problems look, it will say something like this. A bacteria culture contains 200 bacteria. What's that value? That's your P, right? That's your initial amount. That's what you're starting with. That's going to be P. And it tells me that the number of bacteria doubles every hour. So doubles tells me I'm using the doubling formula, and then hours just tells me that my time, in this case, is in hours. So write the function y to represent the number of bacteria in the culture after x hours. So here we go. Y equals, so we're replacing a with y, only because it told me to. And then my principal amount, y'all said, was 200 times, I'm doubling it, so 2 raised to the time, which they told me to call x hours. That's my equation. Now, listen, I don't think you guys would make this mistake, yet this mistake is made quite often, so please listen to me. I am not changing this equation to 400 to the x power. Yet I see people do that all the time. Why can I not multiply 200 by 2? PEMDAS. You guys learned it a long time ago, right? Exponents comes before what? Multiplication. I can't multiply 200 times 2 because 2 is being raised to the x power. Does everybody understand that? Now I can say that until I'm blue in the face. Somebody makes this mistake all the time. Okay? So be careful. You cannot multiply that initial value out front by the base of that exponent because multiplication comes after exponents. So this is my equation. Don't change it. Now, what if I want to find out how much is in the culture after 6 hours? Yep, you simply replace 6 in x's spot. So you're going to go 200 times 2 to the 6th power. And you're going to use your calculator because I doubt many of you guys are going to do, well, maybe you can do 2 to the 6th power in your head. It's not that bad. But more than likely, you're just going to type it in, and in one fell swoop, you're going to get what value? What'd you say? Oh, yeah, but what's the answer? 12,800. And what is that? Bacteria. 12,800 bacteria. Okay, listen. It really is this easy, okay? Don't think that's too easy. It really is that easy. No problems, okay? Now, next. Each day, an investor deposits 3 times as much. Guys, what's 3 here? Is that my P value? No, because it says each day they do 3 times as much. So 3 times is representing that I'm doing what? Which means I'm tripling my value, right? I'm using the tripling formula. Now, as it keeps on going, it says her initial investment is $2. That's my what? That's my P. That's my principal amount. So here's my equation. Write a function to represent her daily deposit, y. So my total amount, y, a, we're replacing with y, equals, what's the P value? 2 times 3 raised to the x. That's my equation. What am I not going to do? I'm not going to multiply 2 by 3 and change this equation to 6 to the x power. Do you hear me? I'm telling you, people do that all the time, and it's wrong. Okay? Do not. Now, how do we find out what her deposit will be on day 8? Yep, you plug 8 into x. So you type in 2 times 3 to the 8th power. And what do you get? 13,122. And of course, that's money. So I put the dollar bill sign, $13,122. Questions about that? So there's your first two equations. Y'all see your formula sheet? If you want to go ahead and roll over there and write those, that way you don't have to memorize them. They're there for when you want to take a test. You can have this formula sheet out, okay? Because I'm not going to write them up here on the board. So you need to have that formula sheet. If you want to memorize all these formulas, it's fine, but I'm not requiring you to. That's why you have the formula sheet, okay? Now, I will be checking the formula sheet to make sure you didn't just like write a cheat sheet on it, but you can use the formulas that are on the sheet even on a test that you'll have on Friday in here, okay? Hopefully. That's the goal. So listen, the next two come from the mindset that over time, the things that you purchase will either go up in value or they'll go down, right? Some things go up, right? Like you hope that your house, you hope that the price that you pay on your house over time will go up, right? But what things kind of don't go up? What kind of things go down? Anything electronic. I can't think of really anything that you would buy electronic that would actually appreciate, right? Can you think of anything? You buy a TV, that's going to depreciate. If you buy a gaming system, it's going to depreciate. If you buy a computer, it's going to depreciate. So electronics depreciate. Cars depreciate, right? You ever heard it said, like as soon as you drive a new vehicle off the property, it's like 25%. I mean, less. I mean, it's crazy. I don't know if it's 25%. But anyways, things will either go up or they'll go down in value. If they go up, when they gain value, we call that appreciates. So appreciation happens when things go up in value. So here are some words that you would look for appreciation. They might say appreciates. They might say increases. They might say grows. So different words that will describe that something is going up. If they go down in value, what do we call that? Depreciation. So some words for depreciation might be depreciates, decreases, decays, right? Those are some words that you might see to represent depreciation. So you've got appreciation and depreciation. And look at the two formulas, guys. What's the only difference between them? One says plus, one says minus. So a couple things. A, we already talked about, that's the total amount, right? P, we called the initial value, the principal. But I want to talk real quickly about the value of 1. Y'all know what that stands for? Y'all know what that 1 stands for? Yeah. And how much is something worth when you first buy it? 100%, right? It's worth 100% of what you bought it for. You understand? So that 1 right there actually represents 100%. If something goes up in value, that means it's worth more than 100% of what you paid for it. Do you understand? But if something goes down in value, it's worth less than 100%. That's why in going up, I add the rate. Where it's going down, I subtract the rate from 100%. Now, with that making hopefully sense to you guys, the next thing I want you to focus on is the R. Let's say the rate is 5%. Are y'all with me? Would it be safe to say that I would plug 5 in and say, well, that's 1 plus 5? No, because if 1 stands for 100%, what would 5 stand for? 500%. So here's the next key, and it's the part that a lot of people make a mistake on. When, Brady, we talk about the rate, you have to change it from a percentage to a decimal. And how do you do it? You either divide it by 100 Or you could just remind yourself to move decimal 2 to the left. Dividing by 100 or just moving your decimal 2 to the left accomplishes the same goal. So for example, the one I just said, 5%. Right now, where is that decimal understood to be? Isn't it right here? Isn't that where it is right now? So if I moved it 2 to the left, what would that be equivalent to? 0.05. 0.05. If I, like Aubrey said, divided 5 by 100, guess what? 0.05. So either way, but that's what has to get typed into the equation right here. You do not type in the 5% like a 5. You put 0.05. Move your decimal 2 to the left. Okay? All right, now let's look at a couple of examples and then we're almost done. We got one more equation and really it's just a modification. It's not its own equation. A plot of land is valued at $30,000. What is that in the equation? That's definitely the initial value, right? What we call it the P. It says the land is expected to what? What is that telling me? Huh? It's going up. It's appreciation. I'm adding. And what am I adding? 9.2%. What is 9.2% written as? 0.092. Look, I either divide 9.2 by 100 or I move this decimal 2 to the left. You understand? I don't care which one you think of when you do that, but I want you to make sure you understand that I'm not going to put 9.2 into our spot because it's not 9.2, it's 9.2%. All right, so here's my equation. Ready? It says write a function. So I'm just going to call it, instead of A, I'm going to call it A of t. That way it looks more like a function. No big deal. I'm not going to count off if you don't do that. What did y'all say the P is? 30,000 times. We're appreciating, so 100%. So 1 plus 0.092, and that's raised to the t power. Now, personally, I like to go ahead and simplify that and just rewrite it as 30,000 times 1.092 to the t power. You don't have to do that, but it will help us when we do the next, not the next problem we do, but the one right after. So there's my equation completely simplified. Now, how do I find the value after 3 years? Just plug it in. 30,000 times 1.092 raised to the third power. So 30,000, type it in, times 1.092 raised to the third power gives you what amount? How much is that thing worth after 3 years?
39,000.
And since this is money, I usually do change. So that would be 12 cents. Okay? Questions about that? All right, next problem. Let's go ahead and knock it out. A new car had a value of $25,200 in 2011. The value of the car depreciated at a rate of 12% each year. Find the value of the car in 2016. All right, so we're just actually solving. They didn't ask me to write the equation, just solve it. So here we go. A will equal, what's P? 25,200 times what? 1 minus 0.12 raised to the fifth power. Landon, why'd you say 5? That's exactly right. The value of the car in 2011 to the value of the car in 2016. 5 years. So literally, I go to my calculator because I don't have anything else. I type this just the way I see it into my calculator, and I'll have my answer. What'd you get? There it is, $13,298.84. Okay, any questions with this? The last part sometimes bothers people because they think it makes something more confusing than it is, and it's just not. So I want you guys to understand something. When we deal with appreciation and depreciation, they're always dealing with time in years. But sometimes they want to know how much does something appreciate or depreciate per month. How many months are in a year? 12. So here's what this formula will do to cause a change in the value. They will take whatever that base is that we had raised to the t power. So you know you had p to the x, or p times whatever that is, 1 plus r or 1 minus r, gives us some value, and then we would raise it to the t power. What this does is, in order to create a monthly appreciation or depreciation rate, they take this value and they raise it to the 1/12. Now, I'm not allowed to change this equation, so what can I do to this exponent to cancel out the fact that I did this to the 1/12? I multiply it by 12, because 1/12 times 12 is 1. Kind of cancels away. So this is the key here. That allows me to change my appreciation or depreciation value to see it from a monthly standpoint. So here's the point. You're still going to rewrite your annual or appreciation or depreciation formula. But then once you've narrowed down what that base is, you're going to write it to the 1/12 on the inside and 12t on the outside, like they've shown here. And then we're going to solve for the monthly. Let me explain. Look at example 5. Andrea purchased a car for $28,000. What's that, guys? That's P. It says that the value of the car will what? So we are taking 1 and we are subtracting 13.1%. How do I write 13.1%? 0.131, right? To the t power. That's my equation. Not messed with at all. Just my depreciation equation. Now, let's simplify inside here. Y'all go type in for me 1 minus 0.131 and tell me what it is.
0.8.
So here's where we're going to make our change. That's how much it depreciates yearly. We want to know, it says monthly. So we take this value and we raise it to the what? 1/12, and we make up for that by raising the outside to the 12t. Now look at what the next question says. What is that monthly depreciation rate? What is, and they're asking about this right here. So go to your calculator and type in 0.869 raised to the 1/12. Tell me what you get. 0.869 raised to the 1/12. 0.98, did I say it here 8? Okay, now listen, we're closer. But remember, we're trying to find out what that is per month. It's not 98.8 per month, is it? Because this was depreciation. And yearly it was 13.1. So how do I figure out what the monthly depreciation is? We take this 0.988 and we subtract it from 100%. What is 1 minus 0.988? 0.012. Guys, change that back to a rate, an actual percentage rate now. Don't we go the opposite direction with the, or we multiply it by 100, either one. But if I move that 2 to the right, 1.2% is how much it will depreciate each month. Okay? Now I want you to do me a favor real quick. What's 13.1 in your calculator? 13.1 divided by 12. How come those don't match? Because that's not how exponents work. So I know that your yearly depreciation rate was 13.1. A lot of times people want to be like, well, can't I just take 13.1 and divide it by 12? No, because that's not how exponents work. That's why you have to raise it to the 1/12, and then of course it will work out correctly. Now listen, I want y'all, we're not going to do the last example, but I do want to tell you one thing, because you'll run into it on your homework. On this one, it was depreciating, right? So when we did this work right here, we subtracted it from 1. But if it's appreciating, are we going to subtract that value we get from 1? No, we're going to subtract 1 from that value. So if you're appreciating it, it's going to be over 1, so you subtract 1, where when you're depreciating, it's going to be under 1, so you subtract it from 1. I think that will make logical sense. Yeah? It does. Okay, so your homework is simply 1 through 8, okay? On this worksheet that I'm giving you right now. 1 through 8. I think you'll find it to be pretty simple. I don't want to say you'll finish it before class is over, but you could probably get several of them done. Tomorrow we're going to do what we call compound interest and continuously compounded interest. That's going to be the one that has the natural base of E. It'll be just as easy as appreciation and depreciation. It just has one little trick to it because of how things are compounded. Instead of being compounded once a year, it might be compounded more often than once a year. So it makes a little difference in the value. So we'll talk about that tomorrow. But your homework, like I said, is numbers 1 through 8.